So manufacturing tolerances means uh, usually we are taking it as one third or one sixth of tolerances of plastic parts taken in the manufacturing tolerances. Manufacturing tolerances, if you compare it with the metal, then you have studied the RA value, RA 1.8, 1.2, 1.3, 1.7 mm like that. Uh, so similar here, we have also instead of RA, we are calling it as a PA value. So it is a, we can call it as a roughness value. For finishing purposes we are taking. Okay. Suppose I will give the one of the example that you guys have studied in the metallurgy. Okay. So in metallurgy, suppose you are manufacturing the shaft and you are going to mounting the bearing on the shaft. Okay. So in such cases, we need to make the finishing of that shaft because we are fitting the bearing on the shaft. Okay. For such a for such cases, uh, you must need to keep some one mm or 0.5 mm diameter. Suppose your shaft is 50 mm diameter, 50. Then you need to keep manufacture the shaft by using the lathe machine as a 50 plus 0.5 mm. And after this lathe operation, you need to make the finishing of shaft. Finishing in such case polishing. For polishing operation, you need to give 0.5 mm. Okay, for smoothness purposes or mm, finishing purposes. So similar here we have manufacturing tolerances. It is one third or one sixth. One third means suppose you have a 10 mm dimensions, then 0.10 mm we need to give 1 mm, 1 mm or 0.5 mm for the finishing purposes, or we can call it as polishing purposes. Okay, so like this. Next is third case is abrasion loss during the use. Okay, so the abrasion and restoration during the production reduces the dimensions of core and enlarge the dimensions of cavity. Okay, so this is a problem which is happening with the patterns and molds. Okay, this problem is totally related to the abrasion loss during the use. It is totally related to the uh, pattern and molds. Okay, so uh, as we know that suppose you take an example of metal dies. Okay, or you can you guys have seen the forging operation. In forging operation, what is happening due to the continuous use of the dies? The dies are getting wear. So in such cases, uh, over dimensions we will getting the over dimension. Okay, so such problems also happening in the plastic industry in case of molds. Okay, so now that is core dimensions are getting reducing, and cavity means holes in metal dimensions we are calling it as holes dimensions are getting increasing. Okay, so this is all about the aberrations. Okay, here some values we have given that is the tolerances. How suppose the dimensions of part is 10 plus plus redefined as that is plus minus. So it's not required to you guys. Okay, so this is how the total tolerance is. The chart is we have. So just to remind this chart. Okay, how we are the total tolerances in plastic industry we are maintaining. But initially, the total tolerances are divided into two cases. First one is manufacturing tolerances, and second one is operating tolerances. Okay, operating and manufacturing. Manufacturing means part manufacturing. Okay, mold related to tolerances means at the time of mold manufacturing, there also we need to maintain the tolerances, mold design by using the CNC machine or process related to the tolerances. Okay, so initially we'll compare this. After mold related tolerances are again divided into two cases here. You just guys see deviation from assumed shrinkage calculations. Means initially we need to define the shrinkage of the part. Okay, while designing the mold. Suppose you have suppose X grade plastic material. So and Y grade plastic material. And suppose X grade plastic material are getting shrinkage by 10%. So that 10% you need to maintain in the mold design. And suppose you have Y and suppose you have Y type of plastic material. And if suppose that Y type of plastic material are getting shrinkage by 20%, then that 20% you need to maintain into the uh, mold design. Okay. Again, mold tolerances, manufacturing tolerances, and wear. Mold wear also we need to consider. So by different wear and wear cycle to cycle, shrinkages, process variations, all these things we need to consider into the uh, parameters. Okay, so you do one thing, and here operating tolerances are divided into change in temperature and change in moisture. This is also in plastic case, this is playing important role. Okay, but in metal case, the change in temperature is not a major issue, and also change in moisture also not a major issue. Okay, so you do one thing, all guys, you take a okay, you take 2 minute time and give this heading and draw this chart. Just to zoom your mobile, so it is visible. Okay, zoom your mobile screen, zoom in and out, so it is visible. Okay, so take a 2-3 minute time and draw this chart. Okay, is it completed? Anybody please reply fast. So is it completed? Anybody please reply fast. Is it completed? Okay, is it easy or it is difficult? Please inbox. So we'll go next part. So the overall things are related to the tolerances. How to maintain the tolerances while manufacturing the plastic product. Means while designing from molded design to the finishing operation. So in a whole cycle, how to maintain the tolerances up to the benchmark. So is it understood? Anybody please reply. Is it understood? Roll number 9, 11, 22. Roll number 8, 7, 6. Is it understood? Is it understood or can I repeat it? Okay. So go for the uh, next part. So this is allowances in plastic. Now we have discussed the shrinkage allowance. Similarly, if we'll see the all allowances that we are providing to the plastic part. Okay. So what I will do? I will share this PDF to you guys. Okay. So whatever the remaining points you have to write in your notebook. We will write the important points, but apart from the important points, if some points will be remaining, then you guys have to write into the notebook. Okay. So to achieve correct part dimension, number of allowances such as shrinkage allowance, draft allowance are considered into the molding. In case of metal, we are just providing the draft allowance, but in case of plastic, we are providing the shrinkage plus draft. Keep in mind, this is for MCQ, such questions they will ask. In case of metal, we are providing the draft, and in some metal material also, they are also getting shrinkage. So, but such minimum number of materials. Okay. So here, shrinkage parameters. Shrinkage is the behavior of every material. It is different from each material to each material. And here we have some plastic materials I have given. So maximum times we are using this material, nylon 6, such PVC, soft rigid, polystyrene, acrylic, and the shrinkage percentage of shrinkage. Nylon 6, the shrinkage material is 1 to 1.5. Okay. And PP material having 1.2 to 2% shrinkage. So this value, you guys just remember this values. Okay. So acrylic. For MCQ, this point is very important. You write this whole page. Okay. Give the heading. Just give the heading allowances in the plastic and write down the whole page. For MCQ, this is very important. So write up to this. For MCQ, this is very important. Okay, so hope you guys have completed it. So go for the next point. So okay, so this is also important as compared with MCQ. Shrinkage depends upon the number of parameters. So for MCQ in university, they will ask shrinkage depends upon following which parameters. So these are the points: holding pressure, melting temperature, mold temperature, holding time, and all thickness. So behavior of shrinkage with respect to these parameters so is important. Okay. So you do one thing, just write down this for MCQ university. Such questions they will ask for your examination purposes. So this is very important. So you take a 2 minute. This is hardly 1 or 2 minute time. So write it. Shrinkage depends upon following parameters. I did 5, 6 parameters. So you have to just write. So write it. Take a 1 minute time and write it. Okay. So go for the draft. So okay. So just a reminder, this 5, 6 graphs we have. So this is shrinkage versus holding pressure. This is shrinkage versus melt temperature. So for MCQ, such questions they will also ask. Uh, okay. So shrinkage increases, then molding temperature. decreases into such questions, so they will ask. So this is all about uh, the shrinkage pressure depend on the parameters. You do one thing. Again, you take a 2 minute time and just to draw this graph. Okay. So hope you guys have completed it. So go for the draft. So we'll discuss the draft. So as we know that why we are providing a draft. So for ejecting the job purposes we are providing. Okay. So now I don't have any animations related to the draft, but in next lecture surely I will show how to what is the use of the draft. So you have guys have studied the manufacturing process subject, then you must know the why what is use of the draft. Okay, so for job ejection purposes, we are providing the draft. So just keep in mind this, and you do one thing. So all things are I have mentioned here related to the draft. So what should be angle? It's point 5. So like this. Okay. So this is not important, but you do one thing. You write in your notebook. So rib design also. Why we are providing the rib? So but means I clear you guys. You have to write in your notebook. Huh? So instead of this, you do one thing. You write here now only. Also. Okay. So give the heading draft design. Okay. So give the heading draft design. Just this is MCQ type importance here. If you see this sentence here, the draft angle of 0.5 degree is regarded as a minimum for the most of the applications. So this is they will ask the draft angle. So they will give the uh, first zero point 0.4, zero point 0.3, zero point 0.5. So you have to make the tick mark for 0.5 mm. So this is just we are not going to dip into the draft design. So just we have overview or related to the draft. Okay. So just give the heading draft design and write this paragraph. Just take a 2 minute time and write it. Okay. So draft and rib. Rib also, why we are providing the rib? Rib, just we are for giving the strength to job. Okay. So for that purpose. Yes, yes, MCQ booklet already I have given, and again, if you will not get, then again I will do one thing. Again, I will mail MCQ booklet. Okay, so don't take tension. I will surely I will send. I will send the MCQ booklet. Okay, hope you guys have completed. So just write down this fast. Write down this fast. We don't have time. So write down this. Okay, so this is also important. Draft angle of 1.5 degree to 2 degree per side are considered normally for the plastic injection mold. So this sentence also very important. Okay, so I will send MCQ booklet, but it is not possible to clear all the 100% thing in the MCQ booklet. So we'll cover it 70 75, but for remaining 25%, you need to prepare from your side. Okay. Okay. So write down the rib design. Write down this. Write down up to this. Write down fast. Don't waste time. Take a 2 minute time and write up to this. write down fast. Now write down up to this. Okay. So hope you guys have completed it. So this is one page just remaining. So, so write down this. Write down this. So otherwise we'll do for next lecture we'll write on it. So I have taken your attendance. Okay. So you guys can left now. So thank you for attending session. I have taken the attendance. You can left now.